explain about a project titled Malicious URL Prediction using ML. And our rapidly evolving digital environment, the internet has seamlessly integrated into our daily routines, acting as a global contact for individuals, businesses, and entities. However, alongside this increased reliance, the exposure to harmful elements like phishing attacks, malware, and spam has grown significantly. A particular concern is proliferation of malicious URL deceitful web links designed to exploit the vulnerabilities and purloin the sensitive data. Amidst this escalating risk, the application of machine learning has emerged as a potent strategy for casting and identifying the malicious URL. Through the harnessing extensive historical data and deploying the intricate algorithms, machine learning models can adeptly differentiate between the benign and malevolent URLs. This proactive approach plays a pivotal role in fortifying the users and the system against the ever-evolving landscape of cyber threat. The central aim of this study is to create a resilient and precise system for casting the malicious URL using the machine learning methodology. By examining an assorted dataset that encompasses both the labeled malicious and benign URL, the research endeavors to establish a model proficient in distinguishing between these strategies with remarkable accuracy and recall rate. The project's specific objective as of data collection and pre-processing of extensive pool of URLs encompassing a range of malicious and the benign instance. Refine the data to ensure its quality and the suitability for the training the model, feature crafting, and of extracting the meaningful attribute for the ML, and the model choosing and training for assessing a variety of ML algorithms like of decision tree, random forest, support vector mission, and the neural network to pinpoint the optimal model, and to find the assessment of the model efficacy using the pertinent metrics like accuracy, precision, recall, and FN score on the distant test data, causing its proficiency in precisely anticipating the malicious URL. For practical applicability to investigate the model's real-world utility by integrating it into the web browser security software and autonomous web service proactively safeguarding the end user from the potential online threat. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. The project commences by importing the essential packages and libraries, establishing the foundation for the malicious URL prediction system using the machine learning technique. And the second one is exploring the dataset. The dataset containing the URL is explored, allowing the insight into the available data for training and the validation. And the next step is data processing. The data undergoes the pre-processing step, including the cleaning and the normalization, to ensure its quality and the sustainability for the model training. And the next step is visualization using Seaborn and the Matplotlib. Data visualization tools like Seaborn and the Matplotlib are employed to create the informative plot and graph, aiding in better understanding the data distribution and the characteristics. And the next one is label processing. Labels are processed and encoded to ensure the compatibility with the machine learning algorithm, setting the stage for supervised learning. And the next step is feature selection. Features relevant for the distinguishing between the malicious and benign URLs are identified, extracted, and prepared for the model input. And the next one is data splitting to the train and the test. The data set is divided into the training and the testing set, enabling the model to learn the pattern and generalize its prediction. And the next one is building the model. The first one is random forest with PCA. It is an ensemble learning algorithm that creates the multiple decision tree during the training and combine the prediction for enhanced accuracy. In this project, random forest is coupled with the principal component analysis, a dimensionality reduction technique. It reduces the number of features while retaining the essential information, enhancing the model efficiency and reducing the overfitting. And the next one is MLP, stands for multi-layer perceptron. Is a type of neural network with multiple hidden layers. It's known for its capacity to learn the complex relationship within the data. In this context, an MLP is designed to discern the pattern in the URL attribute that indicate the malicious intent. And the next one is SVM, stands for Support Vector Mission, is a powerful linear classification algorithm that identifies the hyperplane to separate the data into the distinct classes. And this project, SVM capacity to delineate between the malicious and benign URL by identifying a decision boundary that maximizes the margin between the class. And the next one is Neobase. Neobase is a probabilistic classification algorithm based on the Bayes theorem. It assumes the features that are independent, simplifying the calculation of the probability in the context of malicious URL prediction. Neobase compute the likelihood of a URL being malicious or benign based on the observed attribute. This approach exploits the probabilistic nature of the problem to make the accurate prediction. And the next one is decision tree. It is a tree-like model that divides the data based on the attribute values, ultimately leading to the classification decision. And this project, decision tree is constructed to discern the key attribute in the URLs that contribute to the malicious nature. By recursively partitioning the data, the model aims to uncover the pattern that aid in the classification. And the next one is KNN, stands for K-nearest neighbor. Is a simple and effective classification algorithm that predicts the label based on the majority class among its k-nearest neighbor in the feature space. And the next one is logistic regression, is a regression-based model adopted for the binary classification task. Despite its name, it is used for classification, and in this project, it established a decision boundary that segregates the URL into the malicious or benign category by modeling the probability of belonging to a specific class, and the model works well for estimating the probability of malicious intent for the given URL. And the next one is user gives the input. Here we build a Flask web interface where the users can provide the URL to the web interface. And next one is the given input is pre-processed for prediction. The input URL undergoes the pre-processing step to ensure it aligns with the model requirement. And the next one is trained model is used for the prediction. The trained model chosen during the building phase is employed to predict whether the input URL is malicious or not. And the next one is the final outcome is displayed. The project culminates in presenting the prediction outcome to the user with the help of Flask as a web interface and displaying its probability score to you. And the execution of the project, to execute the project first we need to open the code folder. And this is the code folder containing of various files within it. And static folder containing of the CSS fonts, images, JavaScript files within it. And the template folder containing of the typical HTML documents like of home, index, notebook, results, sign-in and sign-up pages within it. An app is a py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a pickle file that contains the information related to the algorithm and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction of the new data or performing the specific operation. And signup.db is a file appeared to be the database file used to store the user information. And the notebook is an IPYNP file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. We need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it redirects to this page containing of the title and some information about it. And then click on the sign up button. Here it redirects to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Redirect to the sign in page containing of the username and password that need to be filled, and then click on the sign in button. Here it redirected to the sign in page containing of an message where we can enter the URL. And I'm opening the new tab and I am typing of YouTube. And here I need to copy this link and then paste this link and then click on the check here button. Here it predicted that URL gives the 89% safe to use. And by clicking on the still want to continue, then it will redirect it to this YouTube page where we can continue with this site. And by clicking on the URL button here, refresh button, we can re-enter the other URL too, and I'm entering this IEEE Explore URL and then click on the check here button. Here it predicted that result of the website is of 95% unsafe to use. In this way, we can predict the malicious URL by using the machine learning. And in conclusion, the research on malicious URL prediction using the machine learning demonstrates the significance of employing the data-driven approach to tackle the ever-increasing challenge posed by the cyber threat. Through the implementation of various machine learning algorithms and the careful evaluation, the study has shown that it is feasible to build an effective malicious URL detection system. The results indicate that the selected machine learning model achieved a high accuracy and performed well in differentiating between the malicious and benign URLs. By integrating such a model into existing security infrastructure, users can experience the enhanced protection against the phishing attempts, malware downloads, and other cyber attacks.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.